All right. For section 2.2, we are going to be looking at quantitative information, specifically whenever it's just one variable that's quantitative. And remember, this is um, information that's based on numerical values. And one of the things we mentioned about this type of variable, it's typically something that you can calculate the average of. But today we're also going to include the median. So let's get started. We've got mean and median. Now, what is similar about both of these is that the reason why we use them is that whenever we have, let's say, 25 numbers and we want to find out like what's kind of the number in the middle, or what's the maybe one way to summarize all the data with just one value. And that's what both of these do. And what we call that is mean and medians give us a central tendency. Another maybe more simpler way to think about it is like if you have 25 numbers, where are most of them at? And that's going to be the center. When it comes to mean or average, you can use either of those two words. We've got our classic calculation, which is that you add up all the numbers and divide by however many numbers there were. Median, I'm pretty sure most, if not all of us, have at some point in life seen where we find the median, which is supposed to be the middle number. Now, it's a procedure, and part of that procedure requires you to first put the numbers from least to greatest. In other words, they need to be ordered. So we're doing like height, we put like the shortest person all the way up to the tallest person. Whoever's in the middle would be the median height. The other thing that's important is just conceptually to know what a median is. It's trying to split your data in half. So like 50% of the people on this side, 50% of them on this side. And another thing to know about median is that it's the number in the middle unless you have an even number of values. In that case, what you'll need to do is take the average of the two middle numbers. And so you'll add up the two middle numbers and you'll divide by two. But let's go ahead and look at an example. Like this here, let's suppose we had these six numbers, and what we want to do is two things. One, calculate the mean, and also find the median. So for the mean, again, this is one of those things that you can pause the video, kind of try it on your own, but go and like add up all six of those numbers and then divide by six. Again, I'm just going to refer back to like the little calculation up there as you get the sum and then you divide by the number of numbers. And again, you would come up with 344 divided by 6. And if you get a decimal, if it doesn't say, again, in 2.1, I was saying at least two or three decimal places. Today, one is fine, but you would get 57.3 for the mean. And then for the median, remember that is the one where you have to first put them in order. Again, go ahead and do that. Um, and again, I'm going to go ahead and do it for myself as well. And again, you're welcome to pause the video if you want to. Here, let me, you want to try it on your own first, but you have your 38, 41, you'd have your 47. And what you may do just to make sure you don't miss anything is kind of like check off or scratch off like stuff that you've already used. That way you can say, okay, well, all that's left is 50, 53, and 115. And this is what I meant. If you have two numbers in the middle rather than just one specific one, to find the median, you'll need to average those up. You'll take your 47 plus your 50 and you average them up, which is 97 over 2, which gives us a median of 48.5. Yeah. And we'll do a bit of this again in the lecture, but um, I want to introduce just one other important thing that's going to be showing up is known as an outlier. An outlier, again, we'll just keep the definition real simple. It's just anything that's unusually larger or unusually smaller. So, looking at the example that we just did, of these numbers, which one seems like, yeah, you look like you don't belong like the rest of the numbers? And that'd be 115. Yeah. So what we'd say about that one is that it's a large number, but it's unusually large compared to the other values. And what we'll do today is just kind of just eyeball them if we see anything that seems just not like the others. Notation, right? There's going to be sample size, and for that we just use a little n. So what I mean by like notation, rather than writing out sample size, like for example, let's say we had like n equal to 100 students. That would just be a quick way of saying, that's how many people were in the sample. For median, it's just an M, right? No lowercase, uppercase, no little special accents or anything. But for average, we're going to be doing a lot this semester with average. And that is going to be depending on whether you do the mean from a sample. Let's say you did 500 US citizens and it came out to be an average of 69. You would use X bar, right? And so what X bar again, if you're ever typing your homework, you can just put out the word, spell it out, X bar. But that's considered a little accent, and that would be different than you having done the average or the mean based off of the entire population. And so let's say it was the average, or again, average or mean, but you had the entire population. Again, the word all is our big trigger word whenever it's a population. So if we do the average of all the presidents and we come out that the average height is 71 inches, you don't use X bar. It looks like a straight line down with a U with it. And this goes by the name of mu. It's a Greek letter called mu. And mu would be equal to 71. So if you are ever writing up a report and you have an average or a mean calculation, if you use X bar, your audience is going to be, oh, okay, it was just based off of a sample. But if you use mu, that's going to give them the idea that, oh, they calculated the mean, but they did it based off of the entire population. So just be careful whenever you use that you use it correctly, especially on the homework. There's going to be hints to whether it was just a sample or whether it was all of the population. All right. And then now we get into distributions. So distributions, and you can see three of them here are the idea of showing you where most of the data is. Okay, where you see larger like humps of data or larger clusters of data, that's where like most of your values were whenever you collected data. But the three graphs that you see there are known as histograms. So histograms, you might also be familiar with the word like bar graphs, except these are based on intervals that are all the little bars or columns are like touching each other. And so the very first one, I'll just go from left to right, is about the amount of sleep that students are getting. And so this really tall stack that you see in the middle or column shows you that students were getting about 6 to 8 hours of sleep. You can see it right here at the bottom. Most of them are getting about 6 to 8 hours of sleep. That's pretty good. And how many, whatever number you estimate that to be, maybe close to about 100 students said that they were getting about 6 to 8. But then if you see this really small stack down here at the bottom right, that's because it's so small because or so short because only about maybe like 5 students who were surveyed said they're getting about 0 to 2 hours of sleep. So yeah, the taller stacks are where you have like more representation, more often that students said, "Hey, that was me," 6 to 8. So it could have been like 6.5, could have been 7, 7.5. But the reason why I'm starting with this one is because it's going to be what are one of our more often referred to distributions, and it's got this one hump, and then it's got two tails here. Let me do a little bit better job of that. Right, so it's got a tail over here, and then it goes up, and it's got this hump, and then it comes down, and it's got another little tail. So this is known as a left tail, and this is known as a right tail. Just made them a little bit bolder. And anytime you see a graph that looks like this, like pretty close to this, where you've got one hump and you've got two similarly sized tails. So it's okay if one of them's a little bit longer than the other, but not by much. If that is what you notice, then you'll be able to say, hey, this graph is, if anything, at least roughly or pretty close to being symmetric or symmetrical and bell shaped. But the emphasis on the bell shaped. In a little bit, I'll show you that there are some graphs that are symmetric or symmetrical, but they're not bell shaped. But this is one of those bell shaped graphs. The other two that we've got left here, one of them has a left tail, one of them has a right tail. Let's start with this one. Here is where most of the data is, right? And so again, and I'll do this first. Let me just kind of circle all this stuff right here. This right here is where most of the data is. And with respect to the context, this is about amount of exercise that students are getting. So most of them are doing about 0 to 5 hours of exercise, and then not very many, very rare or very few said that they were getting doing 15, 20 hours a week of exercise. But this would be considered where your big cluster of data is. And then what I'm about to start going over right now is the tail. This is the tail, more specifically a tail that is on the right side. And so for that reason, this one is considered to be a skewed, the shape of the shape of this histogram is skewed right. As opposed to this one over here, this is its tail right here on the left. And then you got this hump where most of the data is. So most of the students had a GPA of about 3.4, 3.5, 3.6. And thankfully, rare or very few had these smaller GPAs. So you've got skewed right. If it's got a right tail, you've got skewed left. If it's got a left tail. But those tails are what they use the word to call the extremes, like extreme high, extreme low. But I think maybe a better word is rare, right? Those tails are those really short columns that you don't see a lot of people who said that's what they do or that's their value. Not a lot of people were saying they had like 20, 25 hours. That's rare. But these are also called the extremes. Or this right here, these are the extreme low GPAs, but thankfully rare, not as many. So you got skewed right, you've got skewed left because it's got this left tail. But this would not be symmetrical bell shape because it doesn't have the other tail on the other side to balance it off. Same thing with this one. This would be skewed right because it doesn't have, the other tail on the left side to balance it out. But these are our shapes, our three basic shapes that we're going to be referring to throughout this section and then also moving forward in the class. And what you want to be able to do with these is sometimes they're going to say, hey, just estimate. Like, what was the mean? What was the median? Again, remember, those are the central values. The one in the middle is your general shape of something that's symmetric bell shaped. And these are the easy ones because these are where your mean and your median are going to be the same, or at least very close to being the same, and at the middle. Your skewed right, these are where they're not going to be the same because your mean is going to be greater than the median. And let's break this down. This guy right here is the skewed right because it has a right tail, right? It doesn't have the, the left tail over there to balance it out. And when you see these two lines, this dark solid line and the dash one, this right here is the median. And why? Remember, the median is the one that's splitting your data 50-50. And I'll do it this way. I'll shade this left side of the line. That would be 50% of the data, like 50% of the students. And then on the other side that I didn't shade it would be 50% of the other side of the students. And what they're going to do is they're going to ask you, like, estimate the median. So you're going to try to chop it where it's about 50-50. And then this other dashed line is going to be about where the mean is, just pulled a little bit to the right. And that's because maybe that right here, there's these really high, extreme, rare values that are going to cause that calculation to get higher than the median. Right now, and those are the two that they're going to ask you for. But I want you to know, usually one little tip that I give to students is like, how do I estimate, first of all, where the median is? This here, even though the textbook doesn't ask for it, is the mode. That's going to be the most tallest stack of either dots or a bar. And the median will be a little bit to the right of that. And then the mean will be a little bit to the right of that. But then if it's skewed to the left, that's when the mean is going to be less than the median. And so all we're going to do is flip the script. And before I forget this little word here, we talk about the mean getting pulled. So for this one, since it's skewed left, because again, the tail's over here to the left, the mean is going to get pulled that way. Maybe because there's some like outliers or some really rare extreme values that are so low that they pull the mean towards that low side or towards that left tail. This would be your median. Again, it's doing the 50-50 split. This would be the tallest part of it would be the mode. Again, the homework's not going to ask for the mode, but you might use that sort of as, okay, this is the mode, and then the median's a little bit to the left of that, and then the mean's a little bit to the left of that. But I say let's just go ahead and try it. Right, let's go ahead and try to do this a couple times where they give us a distribution. I really like these. This is not a histogram with all the bars. It's the dots, and so it's called a dot plot. What I like, the reason why I say I like these is because you can still see every single individual person, and you can still see where most of the data in terms of this is about height, how tall students were. You can see most of them had a height of about 68, 67, 69. The shape of it, go ahead and just do like a curve. That's pretty good in terms of it. That looks like a bell, right? You got the one hump and you got a tail on the left that's balancing out pretty good. The tail on the right. So symmetric slash bell shaped. And what I want to say is if there was an importance of, do I have to say symmetric and bell shape, or can I just say symmetric? Or can I just say bell? You cannot just say symmetric or symmetrical because there are some graphs out there that are that are symmetrical but not bell shaped. They've got to have just one single hump. So go ahead and just put both words, symmetrical and bell shaped, whenever it looks like this. But if you forget either of them, don't forget the bell, right? The bell shape is the one that's got just this one hump and two tails. But I'll show you, I'll talk about that again in a few moments here. But as far as like what we're going to do with this is we're going to estimate the mean and the median, which I would just go ahead and go with 68. That kind of seems like a good enough spot. Now, if you feel like no, I want to move it over to like 69 or something, that's kind of up to you. But as long as whenever you come to a graph like this, if you end up saying that, yeah, I think the center 68, and whenever it's symmetrical bell shape, then you need to also say that the median is also about 68. Okay, but if you said 69, then both would be 69. The whole concept is if it's a graph that's symmetrical and bell shaped, that they're going to be the same. But they're not going to be the same here because now we've got one that again, think just take a few moments to yourself. Is this symmetrical? Is this bell shaped, symmetrical bell shaped, or is it skewed left, skewed right? And again, if this is still kind of new terrain for you, again, sometimes I have students who accidentally say the wrong thing, but where's the tail? The tail is on the right. And so this is skewed to the right. And we can also go ahead and just do a kind of general shape of it. And here's this long tail. Or I'll write it this way. I'll write it this way. It's got it's got a right tail, so it's skewed right. And so what we're going to do with this is again that estimate of like where's the mean, where's the median, but because it's skewed right, this is what we're expecting that the mean is going to be a little bit more to the right than the median. But what I'd recommend, as we make a note, mean greater than median is first start off with the median, and again that's just a lowercase m. But where would you split this if you were going to be cutting it 50-50? Now, don't use the rectangle. Don't cut it right here. That's not the median because remember the median is trying to split the data, the dots, right? The people, right? If this is people now, actually this is about movies, right? This is about all movies to come out in Hollywood in 2011. So for now, just think of it as like this way, right? Just a sort of a very um, I don't know, analogy or whatever comparison. Suppose all these dots were like people, and we were going to play like dodgeball, and you're going to split them into two teams. Imagine if I were to split it like right there. That right there would be a really big team compared to this little teeny tiny team where they're going to get crushed. So where would you split this so that the two teams were more evenly balanced, where you've got enough players on the left side of the line, enough players on the right side of the line? And again, just take a few moments to think about this for yourself. Where would you cut it? Again, this would be where I have it split right now would be bad, but would not be a good split. The team on the side would be huge compared to the team on the right. I think maybe a better spot to put it would maybe be right about here. I think that's better. I think the amount of dots that are here kind of match more the other side. And that's kind of like maybe 100. Now, when you now go on to doing the mean, again, you'll have during the test, remember you can have a reference sheet, which is like kind of a little, a one-page reference sheet where you've got little notes and reminders. And one of those reminders is going to be these. You're welcome to draw pictures on your reference sheet that the mean is going to be a little bit to the right And so when you do this, don't move it way over here. That's not a little bit to the right. Just nudge it. Like maybe right about here. Which if I called the first one, I'll do it this way. If this right here was 100, then the mean's maybe like 120 or 125. But notice that I put mu, right? Mu is either X bar or mu. And the reason why I did mu, or why you would do mu on the homework, is that this is a population, a population mean. And again, the little trigger word that we get for population is that word all. So you might just make a little note to yourself. That's going to be your big giveaway that it's a population. If they say all of the movies or all of the students or all of the penguins. Now we'll do another one of these, but for now, just do a quick little. Um, Again, these are large values, but these three are unusually large values. And so these are three movies that made a lot of money, right? They a lot of money whenever they came out. And it's like Pirates of the Caribbean, Transformers, and Harry Potter. But go ahead and estimate what you think these three values are. And I want you to do it first before I do it, just so that whenever you're doing the homework, you're checking the answer key. You're like, oh, hey, his numbers and the answer key are a little bit different than mine, but they're pretty close. As long as they're pretty close, my numbers to your numbers to my numbers are pretty similar, then we're going to be good. All right, but here's what I went with. Again, hopefully, again, you've taken a moment to just try that for yourself. Again, pause the video if you need to, but here they come. I went with about 1050, 1100, and 1300. And again, if your estimates were pretty close to that, then good job. We're gonna be happy. We're gonna move on. Now I'm reusing the example from earlier that when we first were doing the shapes. This is skewed left because of the left tail. Again, we don't see any sort of like tail to the right to balance this off. So skewed left, which now I picked this one because now this is one where the mean is going to be less than the median. And I want you to look at this and think about these sort of now these are about um, the context of this is grade point average, but for the moment I just want you to think of like these are like stacks of money. And imagine me and you were gonna like share this money, we're gonna cut it in half, and I were to cut it like right here. I don't think that you're gonna pick this side, right? You're gonna be like, oh, I'll take this side, right? It's got all the money on it. But what if we were to split it right about there? Would that be about the same amount on the left side as the right side? I still don't think so. And I hope you agree with me. No, I think if we split it there, you would probably pick these three really big stacks. So here's where I'm leading to is that probably here would be of the enough trial and error. I think that's going to be the best spot, which is 3.5 for the median. Again, I'm going to do it. I feel like these two stacks kind of balance out pretty well with those other four stacks. If you were to take the four stacks and like join them all together, so let's just say we're happy with that, right? Where the median is about 3.5, so that the mean, and you're like, wait, why are you doing X bar? It's a sample average or sample mean. And again, remember the biggest advice that I can give you to this is when you do the mean and you know that it's skewed to the left, don't move it very much. Like don't come way over here. I would say just ever so slightly, just nudge it. And so if you're wondering, is this okay to even just go through, cut a column up in half? That is okay, and that would be maybe 3.45. I'd also be okay if you were like, well, I'm gonna go with like, oh, actually, excuse me, I realized I wrote 3.5 right there. If you're like, wait, I think he messed up. Yeah, this would be 3.6. And then let's say we did do this. I'd be okay if you went with like 3.4. That'd be okay. But I'm gonna go ahead and cut it in and slice one of these in just so that you can know like this is okay to do. Right? You're not bound to have to go with the in between the bars. You're welcome to cut one in a piece there. So this would be 3.5 for the mean. There we go. But the only way that I could count this wrong is if it is skewed, but you said that both are the same, as opposed to saying that the mean is a little bit like you saw me there, right? I was about to put 3.6, 3.6, but yeah, it would need to be that you've got your median as best you can, slicing it 50-50, and then your mean would be just a little nudge to the left. And again, just nudge it. Yeah. All right, now let's try another stack key. Again, we did one in the last section. In this one, we're going to try one where, again, it's just using the one quantitative variable, and it's about cars, and more specifically, how many miles per gallon that they get. And all we want to do is just go to use stack key to make the distribution. And of the two, you can either do histogram or dot plot. And mainly just to look at the shape. Is it skewed left, skewed right, roughly symmetric bell shaped? But that's the data set cars, fourth edition, city miles per gallon. All right, let's go ahead and go into stack key and find that. Cars, fourth edition. And you remember, if you're like, wait, how did you get to stack key? Just in your Safari or your Google or your Firefox, just type in stack key. It's gonna be the first thing that comes up. Boom, this is the homepage. And then now we'll go to the one quantitative variable. Again, these are the data that they collected is already preloaded into StatKey. And then you'll go here and you can see it right there. There's the cars. Now, careful, there's several about the cars. Right now, we're doing the city miles per gallon. And fourth edition, right? Third edition is now the old edition. Fourth edition is the new thing that we're using. I'm going to go ahead and click on it. There's the dot plot. There is the histogram. Again, you can toggle back and forth between the. We'll do box plot at a later time, but either one that you look at, I mean, you're gonna see that yeah, it's they're skewed to the right. Histogram even shows it even more skewed to the right. Yeah, so that's the short answer, skewed right. And again, remember, anytime that you have an exercise on your homework that says go use technology, go use StatKey, that is what you're using, StatKey. That's the requirement. And to get credit for that homework, you need to make sure you take a picture of this. So either screenshot it or even just with your phone, as long as it's not all blurry, take a picture of it, make sure that gets uploaded with the rest of the homework that you write out. But yeah, skew to the right. And then you can't just write skewed right and not attach your stat key. You got to make sure if you want the points for this problem, whenever it comes onto your homework, whatever the problem is going to be in your homework, it's a stat key. Attach that stat key graph or image to get your credit. And I think there's not much left. Yeah, this is actually we're going to be wrapping this up pretty soon. All I want to do is just illustrate sort of like why do we sometimes see the mean not the same as the median, and it's because the mean gets pulled by outliers. But let's start with A here. This was a study about these ants who were um, there was a sandwich, and the ants sometimes would certain amount would go and attack the food, and they did it one, two, three, four, five, six, 7 times. And so let's calculate the average of number of ants that were attacking these sandwiches. And so we'll do mean. And again, if you want to pause the video and go ahead and try this for yourself, just add up all 7 numbers and divide by 7. And if you get a decimal, just keep one decimal place is fine. But again, I'm going to go ahead and do it. But again, pause me if you're like, nope, I want to try it first. Get 35.9. And then let's go ahead and do the median. Again, remember for this, you have to put them in order. And then whatever number's in the middle is the median. Again, I've already done this one ahead of time. Again, if you want to pause the video and try it before I spoil it, please do so. But it would be, your 19, 22, 25, 36, 43, 47, and 59. And earlier we had one where there was 2 numbers in the middle, so we had to average them. Now there's only just one number exactly in the middle, so 36. But the point here is that whenever there's no outliers, both your mean and median should be pretty close to being the same. Maybe not exactly, but pretty close to being the same. But suppose when they had done this study, they did run into an outlier, a 159. So we'll repeat it again. Again, go ahead and pause the video if you want to try doing the new mean and the median all over again just for practice, but I'm going to go ahead and do it. You would add up all 7 of the numbers, and you get 351 over 7, which as a decimal would be 50.1. And if you put everything into order, even with the new outlier, your middle number would still be the 36. So the only thing that changed was the mean, but the mean changed a lot, right? It went from like 36-ish to now like 50. And so the whole moral of the story and the reason by us having sometimes the mean more to the left or mean more to the right is because it's affected by outliers. But one thing that they'll say about the median in regards to outliers, they're considered to be resistant. And so, just as we saw in the illustration there, the median was 36, and then even with the outlier, it was still 36. So it's always going to be, again, if the true false question, there will be true false questions on the test. And one of those tends to be, outliers. Which two do outliers pull? Is it the mean or the median? It's the mean. And then the last little thing that I'll leave you with is, again, remember that you've got some distributions, histograms, dot plots that might be symmetrical, but not bell-shaped. This is bell-shaped. One hump, 2 similarly sized tails. These are the ones where your mean and median are going to be the same. This here is symmetrical, but it is not bell-shaped because it has 2 humps. It's got to have just one. But what is still true is that, yeah, the mean and the median would still be the same and at the middle because of the symmetry. And here I'll do one more for you. What if I had one that looked like this? Like one, two, three humps. Same thing. Mean and median in the middle because of the symmetry, but not bell shaped because it's got three humps. So the whole idea is that if it's something that's bell shaped is one humped, right? And that's why I said don't put the emphasis on the word like symmetry. That's important too, symmetry, but uh the key word is the bell shape that we're looking for, right? One hump. But I'll go ahead and end it there. One, stop sharing my screen, and then also go ahead and end the recording. But again, reach out if you run into questions. Take care.